All right, when we talk about exponential functions, one of the times that we see that most often, exponential functions, is when we're talking about interest, and specifically when interest is compounding. And this could be either good interest, like I put my money into a savings account of some sort, and my money is earning interest and it's compounding. Unfortunately, most savings accounts do not compound enough, nor is their interest very high. um, and conversely, we see interest and compounding interest when we have something like a credit card. So if I have a credit card and I don't pay my bills, then interest on what I didn't pay gets compounded, and that'll usually happen daily or continuously, and that can really, because it's a exponential equation, it will grow exponentially. You will go further and further into debt. How much you owe will increase greatly. So, but you can also make money that way too. So I wrote down here a compound interest. So this is interest that compounds n times a year. So we have a couple. This is A equals P times a quantity 1 plus R over N to the NT power. So there's a lot going on there. So let's just make sure we understand what the different pieces are. So we have A, which is the final payment. How much, if it's an investment, how much we're going to get after a certain amount of time. If it's compounded, how often and what rate. Or if it's something where we're paying, how much we're going to have to pay. Okay, and then P is the principal. That's the initial amount. So the initial amount that you put in. So again, this is looking more in terms of the investment side of it. If I put in, $1,000, do I put in $5,000? How much am I going to make? R is the interest rate. So anytime you have either a loan or you've taken out a loan, or you've invested money into a savings, there's some kind of interest rate. You're going to get paid interest on it. So what is that interest rate? N is the number of times a year you gain interest. In other words, that term compounding. So how often, is it monthly? Is it quarterly? Is it once a year? How often am I getting paid interest on that money that's there? And the neat thing about compounding interest is that you continue to get interest on the amount you have in there plus the interest that you have, and then you get interest on that, and then on that, and that's why it becomes exponential. So the whole idea of this is a exponential equation. And then lastly is T, which is the number of years, days, or months that you're going to have that investment. So again, that is compound interest if you have your usual maybe daily, typically monthly or quarterly or yearly. There's another one here that's called compounding continuously. So continuously compounded interest. The equation is a lot simpler, but you don't see this very often, quite as often. But a lot of the same features. So A is a final amount, P is a principal, the initial amount that we put in there. But in this case, E is this what's compounding continuously, and E is approximately 2.72. Do not ask me. I will look it up. I keep forgetting every year, but exactly where that number came up, I'm not exactly sure, but it has to do with logarithms, and we're going to get into that in a minute. But I need to figure out where E came about. I think I knew at one point, forget. Anyway, and R again is interest rate, and then T is the total number of years, months, days. All right. So, we will either compound, once a year, or we'll compound quarterly, which would be 4 times a year, or maybe we compound daily, 365 days, or we ultimately compound continuously. Okay, so there's 3 really quick problems here, or no, one problem, but just 3 different ways of looking at it. So we have $1,000 investment. Again, that's going to be our P, right? That's our principal. And then we have 6.5%, and that is our interest. And I hate to say it, I shouldn't have to say it, hopefully not, but or interest rate, so that's our R. Let me clean that up a little bit. This is our R, which is our interest rate. And for those of you who forgot, if we have 6.5%, we're talking about 0.065. So that's the multiplier there. And then the value of our investment in 11 years' time. So that's our T. So how much will we have made in 11 years' time based on all this? So we'll use our equation, and we have A equals our principal, 1,000, times 1 plus our rate, which we said was 0.065, and that's going to be over 1, which is our N. And yeah, because it says compounded annually. Forgot that part. So compounded annually means just N equals 1, right? 1 year. So this is going to be 1. And then up here, our exponents are going to be 1. Let's find our, 1, because N is 1. So 1 times our time, which we said was, or what was it? Oh, our time is 11 years. Okay. All right, so N number of times a year you gain interest. So we're going to only do it once a year. And then time, we're going to go for 11 years. All right, so ultimately we have to plug that in our calculator, but A equals 1,000, 1.065, and 1 times 11 is 11. All right, so our equation simplifies down, reduces down to A equals 1,000 times 1.065 to the 11th power. We're going to have to use our calculator for that, and we get approximately $1,999.15. Which isn't too bad. I mean, well, actually not that great, but I mean, 6.5% is more than it's about inflation. It's kind of what typically, historically, the stock market's about 7%. So if you can invest something at 6.5%, that's pretty good. Okay, compounded daily. What does that mean? Compound daily means that N is going to equal 365, because that's how many days in the year. So A equals, again, 1,000. 1 plus 0.065 over 365. Because it's compounded daily, then that value for N, which is the number of times a year, because it's compounded every day, they compound it, right? And then for our variables up here, similar to what we had before, it's going to be, instead of 1 year, it's going to be compounding daily 365 times 11. So again, this problem here, you can't really do this problem without a calculator. We are going to move into some stuff where we'll be using a calculator, but mainly get the setup, okay? We may have you do this without a calculator, and we'll only expect you to get to the setup portion. But ultimately, A equals 2,044.06. Okay, lastly, compounding continuously. This one's a little bit easier because we have a much easier equation. So we go A equals our principal, 1,000 times E to R times T. Our R is our interest rate, 0.065, and then how long for 11 years. And then we plug that into the calculator because we can't really do that in our head. And it's going to be around 2044.19. So not a huge difference, but you will notice that there's definitely a difference between compounded annually, so once a year, compounded daily, so every day, and then compounded continuously.